One final video for our seniors. Here we go. We're talking about electrical protection devices. In our last video, when we were talking about parallel circuits, I said that every time you plugged a new appliance into your house, what you did was you created another branch in parallel. That picture got pretty gross there pretty quickly, right? And that each branch would get its own current. And that all those currents combine together to create a really large current, so that IT, the current through that battery or the source, was equal to I1 plus I2 plus I3 plus I4 plus I5 if I added a fifth branch, so on and so forth. It's not that this current would split up amongst these, it's that every time you added something, another current arose. And the problem is if the current gets too high, so like in each of these, like if this was 1 amp and this was 2 amps and this was 2 amps and this was 4 amps and this was 5 amps, each of these wires might be able to handle 1 amp and 2 amp and 2 amp and 4 amp and 5 amp. But when those combine together, that would be 14 amps down this wire. And what happens is when wires have too much current going down them, they get hot. And if they get too hot, they can melt. And the wires are inside your walls. And what happens is oftentimes the main wires are actually attached to the frame of your house. They get like, and conduit like against the frame of your house. If you've got a wooden frame, or even if you've got a steel frame and those wires get too hot and they melt, sometimes they catch fire, and that could cause an electrical fire. And if you have an electrical fire within the walls of your house, that's exceedingly dangerous because you don't even know it's there. Normally we know fire is there because of smoke, but if the smoke is captured entirely within a wall, you won't know about it until the fire has eaten away the entire structural structure of your house. And then you know about that fire when the top floor of your house collapses on the bottom floor. It's not a good way of figuring out that there's an electrical fire. So we don't like electrical fires. They're very dangerous. So what do we have in terms of electrical protection devices? What we need is something that when there's too much current, it shuts the everything off. And so one way is we know that if we don't have a closed circuit, current doesn't flow. So what we want to do is put something in series with the power source that acts like a switch. And so what are those things? Well, there are two protection devices I want to talk about: the fuse and the circuit breaker. Right? And depending on how old your house is, you might have one versus the other. So a fuse essentially is, and you might see this, if you have a fuse, you have a fuse box somewhere in your house, and it's a panel with a bunch of little screw-in, what looks like light bulbs without the bulbs. But inside of those, so it looks like this, and here's the screw part of it. Inside, there is just this one wire, right? And what happens is, if too much current goes down this one little wire, the current causes this little wire to melt. And you choose a wire that will melt at a lower current that will cause the actual wire in your house to melt, right? And so you'll see a fuse like a 4 amp fuse. If more than 4 amps goes through this little wire, it melts, and because it's in series with the battery, it opens the circuit and current stops flowing. Or you might have a 5 amp fuse or a 10 amp fuse, whatever it is. Every fuse has a rating by current, and that's the maximum current that can go through that. What's the problem with the fuse? Well, with the fuse, what happens is it's called the fuse blows. You have to find the fuse box, and that you have to then put in a new fuse. These are one-time devices. Now, here's the thing. Before you get a new fuse and put it in, what you want to do is you want to go around all the things that cause that to blow out and turn them off or unplug them. So what are things that most likely cause fuses to blow. Or actually, let's talk about circuit breakers, and we'll talk about what things are most likely to do that. A circuit breaker is a little bit different because it's not a one-time thing, it's a switch. A magnetic switch, actually, that also has a current rating. And if it exceeds that current rating, what happens is that switch flips off. In your bathroom, it probably doesn't look like a normal on-off switch. It looks like a red button, but that's a circuit breaker, and that thing pops out if you have too much current going through that. And then you have to go around and like unplug things. Just go with me for a little journey around my apartment here. Okay, my main hallway there. Actually, here, ready? I'll picture it's the door of my parents' house in Ireland. Anyway, it's right here in my main hallway, and you can see all these switches are on right now. You can see the on, right? You can see also the other numbers, 20, 20, 15, 15, 20, 20, 15, 20, 20, 20, right? That's because these are fairly high amperage things, and they're all on. So what would happen if too much current, it would flop into the off position, and then I would go around my apartment and turn the things off that cause it to trip, and then I would put the switch back into the on position, right? And you notice my apartment, which by the way is about let's see. I have a living room, I have a foyer, I have a large kitchen, I have 2 bedrooms and 2 bathrooms, and it has 10 circuits in it. So there's 10 individual groupings of things that can go on and off. And I'll tell you, these 20 ones are mostly hooked up to individual circuits that are hooked up to my air conditioners. All right, so coming back here then, your house, which is larger than my apartment, probably has a number of additional circuit breakers. Your average size house probably has about 20 or 25 circuit breakers, and they usually are grouped geographically. Like one circuit might be one room in your house, so that if something blows in that one room, it doesn't take the entire house out. It depends on how your house is wired and when it was wired. So what sorts of things have you seen have blown fuses or tripped your circuit breaker? I kind of hinted before with the air conditioner. Remember in the power video how I said that things that regulate temperature are oftentimes things that have high power usage. That's because they draw a lot of current. So things that regulate temperature, which is why in the bathroom, things like hair dryers, because they heat up the air, or curling irons, or flatteners, whatever, anything that manipulates temperature is more likely to trip the circuit breaker, or blow the fuse, and other things. So what you definitely don't want to do is, if you're doing these things, is leave those things plugged in, go around and find all the things that manipulate temperature, take those out first. And so those are sort of internal reasons that a fuse might blow or a circuit breaker might blow. Another thing is, most common, think about what a power strip is. A power strip is just allowing you to add on extra parallel circuits. If you have too many things plugged into a power strip, that could do it. Now, normal power strips are like 4 or 5 plugs long, and it usually can handle that. But you wouldn't want to plug in 5 temperature regulating devices into one power strip. That would definitely cause that circuit to blow. Or what people do all the time, they plug a power strip into a power strip into a power strip. They like daisy chain them. And that is just so dangerous, because what you want to do is you want to distribute them, because all those, now you could plug 15 things into that one circuit in your house that might only be able to hold 20 amps before it blows. You're better off, if you're doing power strips, to do them out of different outlets in different rooms, or at least different parts of the room, because if you have a large enough room, you might have 2 circuits in that room, so only half the room goes out. So I just thought it was just important that we talked about these electrical protection devices. Not that you have to do anything with this in terms of an assignment for me, but just in terms of being a responsible citizen, knowing how these things function. The important thing at the end of the day is these are all in series with the power source, and they allow us to divide up our house into a bunch of different circuits and chop off the current flow before it gets too dangerous to those parts of the circuits. Now, I will say one last thing. The other thing that could trip circuit breakers or fuses is not something internal, but something external. For example, if lightning strikes the power line to your house, sometimes that causes an electrical surge and trips all the fuses, or all the circuits or all the fuses. That's not something that's internal, that's something that's external, but that's once again done to protect all your devices, because rather than your devices generating too much current, that could send too much current to your devices and cause them to blow up. But thankfully, you have these electrical protection devices in your house. I think that having watched this video, you have an obligation to know where your circuit breaker or fuse box is in your house. It's usually somewhere in your basement. So I would go find that and just look at it. Don't touch it, just look at it, just so you know where that is. And then when you go to have your own place, always know where your fuse box is, always know where your circuit breaker is, because those are things that you just should know as a responsible human being.